Going on, class? Mr. Suffering here. I hope all is well with you and you are using this day to be the better versions of you than the previous day. Okay, so today what I want to do is cover conversions, because in our section in calculating circuits as well as thermodynamics, there are a lot of conversions. So I want to go over conversions, give you some practice problems so you feel confident in these upcoming units and lessons. So let's get to it. So a unit conversion, they're very necessary in engineering as well as science, to work across different systems of measurements to express quantities in different units within a single system. That is pretty much the definition of a unit conversion. When converting different units, there is a conversion factor that is essential to making your conversions. So what a conversion factor is basically a multiplier for converting a quantity expressed in one set of units into another or an equivalent expressed in another. And there are four facets that I want to talk about with conversion factors. Firstly, a conversion factor must be multiplied by a quantity to convert that quantity into alternate units. A conversion factor is a ratio or fraction in which the quantity in the numerator is equivalent to the quantity in the denominator. Okay. Thirdly, a conversion factor contains desired units that is located in the numerator of your fraction, and the given units is located in the denominator. And lastly, the value of the conversion factor is 1. Okay, so let's talk about those four facets that make up a conversion factor. So on my sheet of paper, here is, and all of this information is in the slide deck that is available to you in Canvas. Okay, so again, let's say for grins, if I wanted to convert 18.2 microamps to our base unit, which is amps. Our given unit is the quantity that we want to convert over 1. Okay, and our conversion factor, like we previously discussed, that our desired units is always in the numerator, and it's equivalent to the fraction or the ratio that's in the denominator, which is our given units. Okay, so that right here is our conversion factor, and that must equal to 1. Okay, so once we convert our given units to our desired units, you have the information you need so you can make your conversion. Okay, so let's say for grins, I have 18.2 microamps. Okay, this is my given unit. Okay, and what I want to do is reference our formula sheet, and that is, if you take a look at page 3 on your formula sheet, there it is, page 3, and that goes over conversions. What we're going to look at is the metric system prefixes. Okay, this box right here, these two boxes, we have a table that is numbers less than 1, and we have a table that our numbers are greater than 1. What I like to do on my formula sheet, I want to go over my prefixes, and I want to just put a number 1, okay, on every prefix. Okay, even on this side, we're just going to put a number 1. And the reason why I do that is because when I read this conversion factor, we're always going to reference the prefix to our base unit. Okay, so we're going to, up here, I like to just notate on my formula sheet base, because these are my base units. Okay, so for grins, we have 18.2 microamps. Okay, how do we use our formula sheet to convert microamps to amps? Well, our prefix is micro, okay? So 1 microamp equals 10 to the negative 6 amps. And that's how we read that. That's why I put the number 1 on the prefixes, because that's how we're going to read our conversion factor. So with that being said, now that I have my conversion factors, and again, the decimal equivalent is right here. So 1 microamp equals 0.000001 amps. So with my conversion factor, my giving units is microamps. Okay. So we have 1 microamp, and up here is my desired units equals, so my desired amp units is amps, and we have 10 to the negative 6 amps. Okay, so now using a conversion factor to cancel unwanted units is similar to multiplying fractions. So what I want to do is I want to just go ahead and cancel out microamps. And now when we multiply across, we can actually get our desired units we're looking for. Okay, so 18.2. Okay, no longer microamps because it cancels out. So we have 18.2 times 10 raised to the negative power of 6, and that equals 0.000182 amps. Okay, so that's how you would utilize your formula sheet to find your conversion factor, which you will get your desired units. Okay, so let's try another example. So let's say for grins, if I wanted to convert, let's say 103.2 centimeters to meters. Okay, so again, 103.2 centimeters is my given unit. Okay, and again, we want our desired units, which is meters, in our numerator, and we want our given units in our denominator. Okay, so now what I'm going to do is I'm going to take a look at my formula sheet to find my conversions. Okay, so you can see my prefix 1 centimeter equals 10 to the negative power of 2 meters. Okay, so what I'm going to do, I'm going to go ahead and just write that conversion factor just as so. So 10 to the negative 2, or 0.01. Okay, now that I have my conversion factor, I can go ahead and just do the math. Centimeters cancel out. I can go ahead and multiply across. We have 103.2 times 0.01 meters, and we have 1.032 meters. Okay, so that's just a quick crash course on how to convert and utilize your formula sheet in using these conversions. And notice that there are more conversions on this sheet that you will utilize: mass and weight, length, time, etc. So you will have a quick work. I'll give you some practice problems on conversions, and when I see you in our next class meeting, hopefully you will feel more confident as we tackle circuits, thermodynamics. Man, and other lessons to come. Okay? Have a great day and God bless. Peace.